Okay, now topic is ice making. So ice making, ito yung ice plant, mayroong ice tank, ice can, brine, yung ano yan, pang heat transfer fluid. Yan mo yung malamig yan, tapos papayelo naman yung yellow. Yung nga, yung sa ice can. Bright agitator. So, para ano yung distribution niya. Ice can tip, ice crane, yan. Like, sa mechanical din, yung ice cream na yan, ice crane. So, can filling tanks, ito yung tubig yan, tapos papasok sa, sa can. Okay, platform, ito yung rain. So, yan ang typical ice plant elevation. So, introduction. The manufacture of ice is still one of the principal needs of refrigeration engineering, and undoubtedly it will continue to be for some time to come, as ice is the cheapest means for short-time preservation of food if the amount used is nominal and if the locality can furnish it at a reasonable price. Siyempre, as the cost of ice is an important factor, a vast amount of research has been put into developing an inexpensive means of manufacture. So figure 1 shows diagrammatically a complete refrigeration plant for the manufacture of ice plant. This is typical. Ammonia compressor, yung belt na drive yung compressor, yung piping. So, nito yung ito naman is condenser. Yung sa loob is cooling coil or evaporator. So, yan. So, ito yung mga parts ng ice plant. Kaya marami nakakagawa ng ice plant ngayon dahil sa typical lang naman yan. So, the building. Unless the cost of land is high, the building should consist of one story on one level, so arranged as to be completely visible to the engineer from some central point. The desirability of ice storage is debatable, but the plant should have sufficient day storage for emergencies. For 60 to 130 ton daily capacity ice plant, the day storage should be from 800 to 1,400 tons, arranged for stacking in 4 to 7 tires. The walls and roof must be insulated with granulated or sheet cork unless a cheap construction involving 12 inches of dry meal shaving on the wall and 24-inch on-drop is desired. Insulation. The floor can be made with 36 to 42 inch of well-tamped soft coal cinders and an oak floor with 1 and 1/4 inch spacing nailed to 2 by 3 inch skid. Sa Pilipinas, sana pa na lang ng equivalent yan, yung ginagamit natin dito, mga insulation. So ito yung plan view of modern can ice manufacturing installation. So ang dinidiscuss natin dito is yung ice block, can ice. So ito yung typical plant. So kukopyahin na lang to. Ito yung planta, machine room. Ito yung mga sa production, di ba? Ito yung mga ice can. So dito naman, siyempre yung mga delivery. Palabas doon, ihilay ng tongs yan. Punta doon, then delivery na lagay sa truck. Okay? The ice tank, it should be of 1/4 inch riveted or welded steel and consists of a single tank up to 100 tons daily capacity. It should be 54 inches deep for the 300 pounds can. Ito yung standard na nakikita nyo. Cans of this ice are commonly used. They are 11 by 22 inch top measurement, yung top view, ng butas, with a 1 inch taper and 53 inches long. And they have number 14 gauge size and number 12 bottoms welded and galvanized. Yung iba siguro nakakita na ng yung can actual sa mga ice plant dito. A can of this size has a capacity of about 315 pounds. So kaya ang rating niya is 300 pounds. And the tank is designed for 11 cans per ton of daily ice capacity, although the frequency tendency now appears to be to make the amount slightly less. So ito pa rin gamitin mo. 11 cans per ton. So kaya kung ang capacity mo kung kailangan mo ng production mo is mga 10 tons o 10 cans, so kailangan mo ng 110 cans. Yan. Multiply mo kasi yan. Tapos yung yellow mo, may ano mo dito. Diba? Number of cans, ilan sa 100 tons, ilan yung cans. So, divide mo nito. I-multiply mo ito. Kung 10 tons times 11 cans per ton, so 110 cans. Diba? May tanong din sa mga board exam nito. Okay? The ice tank. So, the brine temperature, ito yung tank. Ice tank. The brine temperature, ito yan. Ice tank, freezing tank. Yung nilulubugan ng can. Diba yung can sa tank? So, the brine temperature should not vary more than 1/2 degrees Fahrenheit throughout the tank. And the variation, and 1/2 degrees Fahrenheit throughout the tank. So, yan ang temperature niya. And the brine velocity should be from 18 to 30 feet per minute. As a result, there will occur about 1 1/4 inch drop of brine level in 60 feet. Some plants have been designed to bleed brine through the bulkhead to stimulate brine flow, but this should be permitted only under exceptional conditions. So care should be taken to prevent excessive bypassing of the brine under the cans and near the size of the can. The brine level should be about 1 1/2 inch above the top of the ice when the freezing process is over. It has been found that otherwise an excessively long time is required to complete the freezing. So if the tank rests on an excavated ground, the ground should be well drained, and 12 inch to 24 inch of well-tapped steam sender should be supplied as a base for the corkboard insulation and the tank. The insulation should be at least 5 inches of corkboard on the bottom of the ice tank and from 12 to 18 inches of the granulated cork on the sides. Freezing of the ground by brine tank may cause buckling of the tank and other more serious troubles. Okay, drain mo siya. Ayan. So, the cans naman ay figure 3. So, ito yung can, di ba? Ayan. Should be assembled in grid to pull a complete row at a time in the medium-sized tank with the 60-ton daily capacity as the minimum size. And from this capacity, the half row is the economical number to lift at a time. The grid should be galvanized and should be weighed at least 50 to 55 pounds per can to prevent floating of the can. If the grid is designed for 24 cans, it should have 4 lifting points. The can should be spaced so that lifting a full row will not drop the brine level more than 1 inch. The modern plant does not use wooden framing but wooden tank covers, which serve as an insulation and working floors, are placed directly on the grid. Yung drop tube, may perforated drop tube naman. Yung drop tube yan, ginaganon. So, the evaporator. Yan. Ito yung evaporator o yung cooler. So, ito yung mga parts niya. Okay? The long trombone, ang design niya, trombone type of evaporating coil is no longer used, but the single pass shell and tube submerged brine cooler, the trunk and the brine resist types are economical of space and eliminating piping between the cans. Where piping is used to, it is short, is tied within with large header to the suction pipe. Okay? So ito yung shell and tube. So ito naman ito yung trombone. So yan masyadong malaki. Shell and tube open type. So the principle underlying evaporator design is to keep all the evaporator surface flooded with liquid ammonia to remove the vapor form as quickly as possible and to have a short suction line with low gas velocity back to the condenser. This permits high values of U for the evaporator surface, about 80 BTU per square foot for the brine cooler and 90 to 120 or more for the trunk or raised design. And cooling of the brine to within 3 to 4 degrees Fahrenheit of the evaporation temperature. So, ito na yung type. Single pass in tube at blind race type. Figure 4B. Next, evaporator pa rin. And the sealing tube blind cooler, some form of separator should be placed in the suction line in order to return any liquid ammonia which tends to pass out of the evaporator as a result of priming. It is generally satisfactory to use one blind cooler up to 50 tons and two, one at each end for 50 to 100 tons daily capacity. The blind velocity is about 2 feet per second in the tubes and about 2.5 to 2.3 feet per second in the race. So valve, figure 5. The low pressure float valve has been found to be much more satisfactory than the expansion valve from the viewpoint both of uniformity and of decreased care in operation. Next, dual effect pre-cooling and subcooling. Since the water used in ice making is ordinarily admitted to the system at a temperature of the city water supply, possibly 60 Fahrenheit or more, a substantial fraction of the load on the refrigeration system will be represented by the need of cooling this water to its saturation temperature at the freezing. If this pre-cooling is accomplished with the refrigerant at the temperature required for the ice tank, it is evident that a large temperature difference will exist, and this part of the load will be carried with an uneconomical low-pressure evaporator. So to overcome this inefficiency, a separate evaporator operating at higher pressure can be used to pre-cool water going to the ice tank. This method will also permit operation with multiple expansion valve and consequent extraction of flash vapor and decompression from the pressure of the intermediate evaporator. So meron tayong maraming evaporator na, di ba? Na-discuss natin yan. Operation with water pre-cooling requires, of course, either stage compression or use of dual effect compressor. Under normal operating conditions, a plant of this kind will maintain from 35 to 40 pounds gauge pressure on the high pressure section of the dual effect compressor. Next, brine corrosion. Both sodium and calcium chloride are satisfactory for use in the ice tank. Brine should be treated with sodium dichromate in amounts of approximately 125 pounds for every 1,000 cubic feet of calcium and 200 pounds per 1,000 cubic feet of sodium chloride. The dichromate is not injurious to the tankman if care is taken about personal cleanliness. The exact concentration of the dichromate varies slightly with different plants. An alkaline solution having higher pH value has a tendency to remove the galvanizing and to cause the growth of sediment on the cans, which act as an insulation and tends to carry brine out and bring fresh water back to the tank during dipping process. A strong alkaline solution also interferes in the test for ammonia leaks, making an extremely corrosive mixture where there is a tendency toward electrolytic action. However, the almost total removal of piping in the more recent plant assists in decreasing this efficiency. There appears to be less corrosive tendency with calcium brine, probably because of more difficulty in introducing air into the brine. So under no circumstances should the brine be permitted to have a pre-fall or have any other opportunity for mixing with air. Agitation. So the brine agitator or propeller, yan, nag-agitate yan dyan, should have a capacity of 60 to 70 gallons per ton per minute. So ito na yung value mo. It may be either horizontal or vertical, although the vertical is more convenient when the mobile is required for repair. The agitator should be of medium speed and of large diameter, and the brine passages should be carefully designed in order to prevent undue loss of head. With tanks of 900 cans, 2 horsepower agitator are usually sufficient, or 1 horsepower per 50 to 20 tons of ice daily capacity. Excessive brine head results in increased kilowatt-hour per ton, which may not be justified by local conditions. Manufacturing factors. Okay. So, ayan yung mga parts. For agitation of water in the can, both high pressure air resulting in white tops and low pressure air with cup tops are used. The ice being of approximately the same quality in its case, where the water is reasonably low in dissolved salt, but as a rule, the high pressure air requires more power and has to be dehumidified. With low pressure air agitation sa figure 7, approximately 0.5 cubic feet of free air per minute is supplied at about 2 psi for 300-pound can and 2.5 psi for 400-pound one. Whereas the high pressure air is supplied at the rate of about 0.2 cubic feet of free air per minute per can. So, ayan. So, yan. So, in low pressure agitation, the air passes through a tube which may be allowed to swing or fasten in a central position. Water for ice manufacture varies in chemical composition so much that the need of operation of each plant must be determined by itself. Any commercial water, even up to 1,300 parts by weight of solid per million, could be used successfully for the manufacture of merchantable ice with brine temperature of 16 Fahrenheit if the air agitation was effective and sufficient core removal was resorted to. The time of freezing of ice can has been found to be a function of the thickness of the ice. Yan. The brine temperature and the amount of brine agitation in it's given by T in us is equal to C times X squared over 32 minus T, where C is a constant varying from 5.34 to 6 in 1/2, depending on the brine agitation. X is the thickness of the ice in inches, and T is the temperature of the brine in Fahrenheit degrees. So example number 1, for a brine temperature of 5 Fahrenheit, calculate the approximate cooling time to freeze a 2-inch thickness of can ice. Assume excellent brine circulation. So given T is 5 Fahrenheit, X 32-inch, excellent brine circulation required is the time. Solution, for excellent brine circulation, the cooling time is fast. So then C is equal to 5.34 or 5.75. So T in R is C X squared over 32 minus T is 5.75 times 2 squared over 32 minus 5 is 0.85 hours. So yan ang time of freezing. So this is the end of the topic. Ito yung ice plant. Hanggang ngayon, ganyan pa rin ang design. Diba? So sa Pilipinas, ito lang naghahaging high-tech yung equipment. Cooling tower, ito yung sa condenser niya. Pupunta doon. Okay, thank you.